Basically, we divide the thing into parallel due to Q lah.
Yeah. Just like let's go back to the concept of electrical circuit, right? So when it reaches that part, so it is divided into two parts, sphere and cylinder, right? So I think mine is correct because after passing through the cylinder, then it is exposed to the air, right? So through the cylinder and through the sphere. It doesn't come back to one point, then exposed to the air. Okay. Anyway, I don't want to drag here. I think I would do some study. Actually, I tried both way. How to say? Because some of you, I see your solution, right? You divide when you try to solve it numerically. Basically, what you did was you calculated Q for sphere and you calculated Q for cylinder. Then you sum it up, right? So, but I did not see you solve your problem based on the circuit diagram, right? I see many groups. Actually, when you try to solve the numerical problem, part 2, your solution doesn't follow your circuit diagram. It's something like you did it. The two parts has no continuation, right? But I myself, I tried both. Okay, then I got very similar answer. But this is the first time I see this lah. This is the first time I see this kind of circuit diagram. Okay, but I dare not to give a very conclusive answer at the moment yet. Okay, so if Liang Hong, you have done the calculation and it shows that there is a big difference, so I guess most probably this circuit diagram is wrong. But I still need some time to so-called to do some investigation to see what is the principle behind. I'm trying to resolve that, to understand that. So can we proceed first? Then after this, only we come back to this problem. Okay. At the moment, I would say the right circuit diagram probably is not like this. Okay. Yishun, could you please stop sharing? I will share one, which I think is correct. Let me see. Let me get one. Okay. I think this is from group 3. Can you see what I'm sharing?
Yes, Doctor.
Okay. So this circuit diagram is same as what I did lah. Like this. Liang Hong, have you tried solving that numerically using this circuit diagram?
Try. On the way, doctor.
On the way. It's okay. I did that before. It gives me a similar answer. So I guess this is the correct circuit diagram. That's why I asked Yishun just now. Okay, but anyway, because I have something else to do during this class, so I don't want to drag the time. So Liang Hong, you can try. Then, okay, my comment, you see, let's say group 3, okay, your circuit diagram is correct. Okay, but just that in terms of numbering, I have some comment. Let's say during the test, you can do, okay, RA, RB, RC, RD, okay. Here is good if you put R in, here is R out, right? Because the temperature here is TI, right? So you put TI, but here is you put R1, right? It's inconsistent. So make sure your symbol, right? The symbol used is consistent, right? With the information given. This will ease your work as well, so that you won't get confused. So group 3, you get the comment, right? Okay, then my comment is, you see part B. So this is the circuit diagram you constructed. Okay, but when you solve it numerically, I see your solution is not based on the circuit diagram you constructed. Group 3, can I have someone to answer this question? Group 3.
Good morning, Tata and Shara from Group 3. I think it's because we just separate do it like the person 1 do the first question and the person 2 do the second question. So maybe it will cause they are different from the question 1 and the question 2B.
But why you guys didn't discuss? You can divide the work, but after that you should gather, you should discuss. I think this is the common challenge lah. When we have group works, then you just divide and conquer.
Yeah.
And after that, you never check your works overall, right?
Because that day actually not enough time. We have some person have the meeting at night and some person having the class at afternoon, but we didn't have enough time to do it. So what we can do is we actually plan for discussion, but no time and we didn't have enough time to do to having meeting.
Okay.
Sorry, doctor.
What I can see is there is no connection, there is no continuation between your circuit diagram and your numerical calculation. You solve the problem using different concept. Your solution to question number 2 is correct, but it is irrelevant to the circuit diagram you draw. So that's my comment.
Yeah,
Okay, what I want you to do is you must change your solution of question 2 by referring to this circuit diagram you draw.
Okay, sure.
Okay, basically I don't see much problem. Maybe the reason is you got solution from your senior. I think most probably you have solution from your senior. Okay, you are blessed enough, you have all these solution from your seniors, but I hope you don't just copy without understanding. In the test, you won't get this kind of question. Okay, I will make sure your understanding will be tested. So please ensure that you can refer to your senior solution, but please make sure you understand it. Otherwise, you will be in trouble during the test. Okay.
Okay. Doctor, sorry,
Yep.
because actually at that time really don't enough time to understand the question, and I hope to understand how to draw the electricity the from the question 1B. Yeah. Actually, I really not understand why draw like this. Yeah. And actually, I hope to understand and hear. So I didn't ask for my partner. This is my question, but I hope can.
But then how did you come up with this circuit diagram?
I this is my for my group mate but
Okay.
I didn't just ask her directly.
May I have the group mate to explain to us?
Not sure.
So which group mate come up with this circuit diagram? So can I have the person to explain to us?
I think is Hajika, right?
Yes, please.
I'm here, doctor.
Yeah.
Sorry, doctor, because I refer to senior, so I don't really understand how the circuit become parallel.
Okay. I will leave this as an assignment to all of you. You try and understand. Is that okay?
Actually, I try to understand,
Yeah.
but actually, I really can't understand why you draw like this. Lah. I hope can get the answer from Dr. Lai. Is it okay? I have tried, but it's not really so easy to understand.
Okay. What is the question that you have? I want you to ask.
Because I see the diagram, but I don't know why suddenly it come through the parallel. And I not, yeah, why it go through the parallel? Oh, yeah, can answer my question. I see he raised hand.
Yeah, Liang Hong, want to say anything?
No, actually, I just want to say my understand lah.
Yeah.
Because before this, to be honest, I also refer to senior question, but simply don't actually understand. But for now, I have a big understanding lah. So from what I understand, the two parallel actually is from the cylinder, and from the second branch is actually the sphere. So I think doctor also understand it like this lah. So one branch is the cylinder and one branch is for the sphere. Because the Q for the sphere, actually two hemisphere lah, is actually the same. And for the Q for the cylinder is actually another Q. So it divide into another Q. So Q for cylinder and Q for two hemisphere actually is a sphere. So two branches lah. And I understand the second resistance.
Why Q for cylinder is different from Q for sphere?
Because the area is different, doctor.
Area is different.
Yeah, because the area, if we directly calculate the resistance, right, the area would be calculated inside the resistance. Right, doctor. Because the X, right, X divide by Ka. No. Actually, using the cylinder, the cylinder formula. Yeah. Sorry.
Let's come back to the very original question, original equation, right? Q depends on what? Depends on temperature difference, depends on
The resistance.
thermal resistance, depends on depends on
Area.
The distance.
area, depends on the distance between the two, right? Between the 2 points.
Oh, okay. The air, right?
So what, okay, if you compare a cylinder and a sphere, then they have different, I think explanation of Liang Hong is correct lah, because the geometry is different, right? So, okay, why for, let's say, a flat plate, it is easier because you see the what do you call that? The surface area is the same, right? So that's why easier for us to understand, right? But for this shape, actually it consists of two different geometry, right? Geometry number one is cylinder. Geometry number two, hemisphere plus hemisphere. So it is a sphere. Okay, and you know equation for calculating the surface area, right? The area of a cylinder and sphere is different. Okay, so that's why when the heat, let's say here, because the heat is being transferred from inside to outside. So it passes through two parts, right? So part number one is through the cylinder. Part number two is through the sphere. Okay, and you also learn in derivation, right? Q for the way how you calculate Q for passing through cylinder and Q for passing through sphere is different, right? So that's why when heat reaches here, so in order to calculate them, you have to divide them into two parts. So one is through the cylinder, one is through the sphere. Okay, so when you pass through, so the R1 and R3 is actually through conduction, right? Through conduction, through this. Okay, and after passing through, then you have the second resistance. This is actually R for convection, right? So that's why I believe this is the correct circuit diagram, because this part convection so take place at this area, right? The sphere area, and this part of convection takes place at the cylinder area. Okay, but I haven't sorted out like just now group 6, right? That they combine this, then only they come to another resistance, right? Another resistance which is convection, and they sum up the area. So group 6, Liang Hong, you have tried this, right? You have tried this circuit diagram, right?
Yeah. But before this, if I'm not mistaken, I just combine all the area. Means that I actually calculate also the the previous the conduction
So
one.
your calculation is not based on that lah, right? Can I ask group 6? Group 6.
Yes, Doctor.
By using this circuit diagram, did you get a similar answer? Have you tried calculating using this circuit diagram?
No, Doctor. I mean, we just two parallel. I mean, yeah, two parallel. We haven't know the two series, right?
Because I see that your solution is also same as group 3, right? You also divide it into cylinder part and the sphere part, right? Is your calculation based on the circuit diagram you draw?
Yes, Doctor. For
Sorry?
the yes, Doctor. For the conduction, yes, but not for the convection.
Did you get a similar answer?
Doctor, you mean similar answer means the answer in the
Two different methods. The two different methods. I think you also use the same method as group 3. You also divide it into R cylinder and R sphere.
Yeah.
So it means your answer is also not related to your circuit diagram, right?
Is it related, Doctor? Because we
Sorry?
get the R sphere and R cylinder, then we use the parallel. I mean, the parallel is resistance formula.
So your solution is based on this circuit diagram.
Yes, Doctor.
Okay, and you get the answer? Did you get the answer?
no, doctor. We get 866 watt.
Okay. I don't want to confuse you guys. Give me some time because I never come across this type of circuit diagram. I think I need some time to sort it out. Okay, I'm very sorry. Okay, I don't want to cause confusion. If I continue to say anything, then you guys get more confused. But at the moment, what I want to tell you is, in my opinion, I think the circuit diagram produced by group 3, which I showed just now, is the correct one. Okay, group 3 punya, yeah. Okay, circuit diagram, I believe this is the correct circuit diagram. Because I tried it, okay, and I calculated using two different methods, I got very similar answer. So I believe this is the correct circuit diagram. Okay, I will try for another circuit diagram produced by group 6 and see if it works. Okay, because theoretically explanation given by group 6, I think to me is acceptable, but I still need some time to sort it out. Okay, we don't have much time. I want to move on. Okay, I want to move on to group assignment 1. Okay, group assignment 1. Okay, I have roughly gone through your solution. Okay, in my opinion, some of the explanation are still unclear. Okay, still unclear. For example, okay, this is the answer by group 6, if I'm not mistaken. Group, let me check.
Yes, doctor. Group 6.
Yeah, group 6. Okay, so I have a question here. Here it says, vigorous vibration of the molecule collides with the surrounding molecules and generate heat energy. Is that correct? Meaning the collision of the molecule generate energy. Is that correct?
Doctor, I think we need to add due to friction, generate heat energy due to friction.
Because I have never come across this explanation. Okay, so I have a question. So could you please check in textbook or any way to see if really like the vibration and the collision of the molecule will generate heat energy. What I understand is the collision transfer the energy from a more what to say, from a molecule with from a molecule with higher energy to molecule with lower energy. That is what happened, but I never come across with the collision generate heat energy. You get my point?
Yes, doctor.
Yeah. Could you please check and verify this?
Okay, doctor.
Yeah. Then another comment that I have is, okay, your radiation, you say both flame and hand emit thermal radiation, and in bracket you put infrared. Okay, this is not really accurate. Okay, but of course you haven't gone through the explanation. Okay, you see, actually thermal radiation is emitted. You see, the theory is, the correct theory is, any surface above 0 Kelvin will emit thermal radiation in a continuous spectrum. Okay, but mostly the thermal radiation is between 0.1 micron to 10 micron, not only in the infrared region. Okay, you see, this is the thermal radiation region. It's between 0.1 micron to 10 micron. Okay, most of the thermal radiation is within this region. Okay, but actually the wavelength in other region also contribute to thermal radiation. Okay, meaning if you say, because your answer you put here, the answer you put here is infrared. So I think this is not accurate. You got what I mean?
Yeah, doctor.
Yeah. So, and infrared region is here, right? After the red. And here is ultraviolet. This is visible line. So actually, thermal radiation is within infrared, ultraviolet, and visible line region. Is from 0.1 micron to 10 micron. Okay. So this is the correct. So I think to save yourself from trouble, right? I think you can just put both flame and hand emits thermal radiation. You don't need to put infrared. Okay, and I have gone through roughly some groups explanation. I think the explanation is not comprehensive and accurate enough. Okay, and I also found, maybe last time during the lecture, I think one of you asked me regarding how heat is conducted through conduction in liquid, right? I think my explanation last time was wrong. Okay, I want to say sorry to you, and I just want to explain one more time. Okay, this is from a textbook, yeah. So I want you to correct your answer. Okay, I want you to improve your answer based on my explanation now. And I also want you to take some initiative to look for answer from some other references, including some of the textbook you can find. Okay, one of the soft skill we want to cultivate among you through this course is lifelong learning. Okay, so please don't expect to just get all the answer from your lecturers. Okay, especially when you conduct your heat exchanger design project, you are required to do some external references. Okay, so in order to help you in cultivating this lifelong learning skill, so I will give comments to your assignment, explanation in terms of theory, and I want you to improve your answer by referring to more references outside. Okay, so this one example, yeah. Okay, you see mechanism, heat transfer mechanism. If conduction, you see the highlight part. Conduction is the transfer of energy from more energetic particle of a substance to the adjacent less energetic ones as a result of interaction between the particles. Conduction can take place in solid, liquids, and gases. Okay, so in gases and liquid, you see mechanism. When we talk about mechanism, you must tell what is the mechanism. I want to see keywords, for example, collision. I want to see keywords, for example, diffusion. Okay, so the correct explanation should be in gases and liquid, conduction is due to collision and diffusion of the molecule during the random motion, right? In solids, it is due to the combination of vibration of the molecules in a lattice and the energy transport by free electron. This is for metal, right? For non-metal, is vibration of molecule in a lattice. So I want to see all these keywords in your answer. Because I have gone through some answer, I only see heat is transferred from this surface to another surface. I don't see the word collision. I don't see the word diffusion. I don't see the word vibration. I don't see the word free electron. Okay, so I want to take note on this. Then, okay, this is conduction. Okay, you see, here is some more explanation. In solids, heat conduction is due to two effects. The lattice vibrational waves induced by vibrational motion of the molecule positioned at relatively fixed position in a periodic manner called a lattice, and the energy transported via the free flow of electron in the solid. Okay, so this is some other explanation, a deeper explanation. Okay, this is for conduction, right? For convection, so here you see a figure, mechanism of heat conduction in different phases of substance, right? In gas, it's molecular collision, molecular diffusion. In liquid, also molecular collision and molecular diffusion. In solid, it's lattice vibration, okay, or flow of free electron. So lattice vibration is for non-metal, flow of free electron is for metal. Okay, this is conduction. Convection, okay, I want to say sorry. That day I gave some wrong explanation. So now I want to correct those things. Okay, convection, you see, what is convection? Convection is a mode of energy transfer between a solid surface and the adjacent liquid or gas. So what you can see is convection is what is heat transfer between a solid surface and a liquid or gas. If heat transfer within solid, we know is conduction. Heat transfer within liquid is also through conduction. Heat transfer within gas is also through conduction. But heat transfer between a solid surface and a flowing liquid or gas is called convection. I think maybe this is something new to many of us. It's actually something new to me as well. Okay?
Excuse me, doctor. Hello?
Someone is speaking.
Yeah, doctor. I got a question about convection.
Yep. Can you speak louder, please?
Okay, doctor. I got a question about convection. If the air is still, so no convection will occur, right, doctor?
Can you say it one more time?
If the air is not moving, no convection will occur, doctor. Is that right?
If air is not moving, no convection.
No convection.
You are talking about convection happen between what and what?
Between the solid and the still air.
Between the solid and still air. No
Yes.
convection, yes. If the air is not moving, yes, there is conduction.
Thank you, doctor.
Okay, some of you might have question. You ask, let's say, okay, let's read this statement. Heat transfer between the block and the surrounding air is by conduction. If the temperature difference between the air and the block is not large enough to overcome the resistance of air to movement and fast to initiate natural convection currents. Okay, what does this mean? Okay, we know there are two types of convection. One is forced convection. Okay, as you can see in this figure 1-35. Okay, forced convection is easy to understand because the air is forced to move, right? By an external force. By natural convection there is no external force, but the air moves because of difference of density, buoyancy effect, right? A heated air with higher temperature will have lower density. That's why it tends to move upward. And the movement of the air causes airflow, buoyancy effect. And this form natural convection. But it depends on the temperature difference. Okay, if the hot egg here, let's say, is very hot, then the buoyancy effect is large enough to form this flow, right? But if the egg is not that hot, right? It's not that hot. Is, let's say, 32 degrees Celsius, let's say, and the surrounding air temperature is 30 degrees Celsius. So temperature difference is only 2 degrees Celsius, let's say. Okay, so the things happen could be, you see, the temperature difference between the air and the egg is not large enough to overcome the resistance of air to movement. So there is no natural convection occur under such situation. Am I confusing you? I'm just trying to get deeper. I'm just trying to go deeper so that we see things in a deeper level. If you have question, please ask now.
Doctor, so if the natural convection is not happen, so only conduction happen, right?
Yes. So natural convection has a condition. The condition is we know natural convection happen when there is a flow due to buoyancy effect. The buoyancy effect is because the air is heated, the air near the hot egg surface is heated. Then it's when the temperature of the air increase, then its density decrease. Then it tend to move upward, right? So unless the temperature is hot enough to heat up the air, then it forms a flow big enough to overcome its own, here it say overcome the resistance of air to move, right? Because you also learn in physics, right? There is what we call resistance to movement. What we call that? Inertia, right?
Yes, Doctor.
Yeah. So unless the movement, the movement is large enough, okay, the temperature difference is large enough to move the air. Okay. Otherwise, actually the air tend to stay stagnant. In such case, then what happens is conduction, not natural convection. Is this clear enough to you? Do you still have question?
So doctor, if the egg is hot enough, so the whole process is like the conduction will go first and then will followed by the natural convection, right?
Yeah. Actually, some scientists, they have a comment. They say actually convection is actually a mixture of conduction plus diffusion. So some of the scientists that don't see convection as a mechanism of heat transfer. Here you say, you see, I highlighted this part. Some people do not consider convection to be a fundamental mechanism of heat transfer, since it is essentially heat conduction in the presence of heat, fluid motion. So some scientists actually don't consider convection as a mechanism of heat transfer. But you see, but the textbook author explained in this way, but we still need to give this combined phenomenon a name, right? Unless we are willing to keep referring to it as conduction with fluid motion. So it is practical to recognize convection as a separate heat transfer mechanism, despite the valid argument to the contrary. Okay, I just want to bring you to a deeper understanding. I don't mean to confuse you. Okay, so the conclusion is we still believe there are three fundamental mechanisms of heat transfer: conduction, convection, and radiation. But convection is a little bit of confusing because convection is actually a mixture of conduction plus fluid motion. Okay, but we don't want to go into that deep lah. So when we explain, we still refer it to convection. Okay, but I want you to understand a little bit. Okay, convection is actually a mixture of conduction plus fluid motion. Okay, and I want you to be able to differentiate when, let's say, a solid, heated solid. Okay, in what situation we can say the heat transfer is through natural convection? In what situation the heat transfer is through conduction? Do you get my point, guys? Or you still have question?
Okay now, Doctor.
Okay, it's 9:02 already. I'm very sorry for dragging you. Okay, what we plan is after this coming Sunday, is the first day of Puasa. So it's a public holiday. So there is no class. But we don't want you to left behind the schedule. So we will still plan something for you to do during the weekend. Is that okay? Because we don't want to have replacement class after this. because losing 2 hours of class meaning we will be behind the schedule. Okay, so we will assign you some works to do during this weekend, okay, so that we can catch up with the schedule. Okay, I see many thumbs up. So very, I appreciate all your willingness to go deeper, to understand more. Okay, so take note on the notification from the lecturers. Okay, we will inform you on what to do. Okay, what we have planned so far is we will give you, okay, for those who have class now, you can leave. I'm very sorry for dragging you. You are free to leave. For those who do not have class, I want to explain to you what is going to happen. First, we have planned exercise. We will give you 7 questions to solve. Those 7 questions are on conduction. Okay, this is the first thing we have planned. Second thing, we might also ask you to go through we might ask you to go through one lecture on convection, because basically we have done with conduction. You might still have questions, it's okay. Just try to go through the questions, the 7 questions. Then we might take some time to explain again, to discuss again. Okay, I understand that the discussion we have just gone through might create confusion in you. I'm very sorry for that. Okay, we will do more discussion after this next week on Wednesday, because Sunday is a public holiday. Okay, I'll be more prepared on that. Okay, you can also prepare your question. If any question, maybe I will share a link so that you can share your question in that platform. Then I can collect the question and try to explain to you. Okay, but one thing I want to emphasize is we want you to also go through the learning lesson, not just get everything from your lecturer. Okay, so we learn together. Okay, actually I only found all this new so-called, to me it's new information last night when I tried to refer to this textbook. Okay, so I hope you also can do some self-study, then we can improve together. Okay, so you have any other question regarding what is going to happen, what you are required to do?
Dr. Cheryl here. So far for the group assignment 1 and group assignment 2, if we didn't, for the group assignment 1, we need to explain, we need to do again, right?
For group assignment 1, I want you to, all of you, unless you are satisfied with your solution already, otherwise, I want you to do a revision. Because so far I have checked a few groups, I am not satisfied with your explanation. It's very superficial and I don't see those important keywords. I don't see the way you explain is correct. Okay. For CLO number 1 of this course is you should be able to explain. I see, based on my experience from previous cohort of students, this is the biggest weakness of the student. You will see this very clearly when you do your PSM, final year project, in final year. When you write your thesis, you will suffer if you don't improve in this area. If you don't have enough understanding on those fundamental knowledge, fundamental mechanism, you will suffer when you try to explain, when you try to write your thesis. So start training yourself in this area. Start from now. Okay, so I want you to improve your assignment 1, group assignment 1. Okay, if you choose not to improve, it's still okay, but you will get very low mark for your group assignment 1. And you will also have problem during tests. Okay, so that's why it's good if you can go through this once again, then you explain, you improve your explanation. Okay? Yep. For this calculation part, I think most of you don't have problem. Just that maybe you are confused in terms of circuit diagram. In terms of calculation, I see that most of you okay. Based on the answer, maybe if you just copy and paste your senior's answer, then I don't know lah. Okay, but you have problem in terms of circuit diagram. That one we will explain again next time when we meet again. Okay, so I guess that's all. That's all for today. Okay, I will stop sharing.